Okay, right. So that part is over. Now, let's come to talk about another practical example of where we use a middleware. So in this example, we will be talking about three things. The first one is second one is the object request broker. This is called the OB. Okay, this is also a type of middleware which we will be using to discuss this. And you have stubs and skeletons, which you already know. Okay. So the two-tier client server is used to describe a computer system where a request is sent by the client and the server responds to the request using its own resources. Okay. So say you have client applications and you have a data source. So the requests will be served using the resources that the server has. Okay, so this is totally fine. This is totally fine if the number of clients that are there is less. But when you have many number of clients, then the server has to struggle to serve the requirements of all the clients. Okay, in this case, we get the help from the three-tier architecture. Okay, so here what happens is in the three-tier structure, in between the two tiers that we discussed before, you have an additional layer which is called the business logic. So you have the client server tier here, and then you will have your database. In between these two, you have something called the business logic tier. Okay. So a type of middleware that can be used in the business logic tier is what we mentioned here as the OB, the object request broker. Okay, so when we talk about distributed computing, an OB is a middleware which allows programs to, which allows program calls to be made from one computer to another via a computer network. Okay, so it provides transparency, etc. through remote procedure calls. Okay, through remote procedure calls. That is why we have stubs and skeletons in this picture. Okay, so what an OP does is, well, yeah, it establishes the communication between the two. In addition to that, it encodes the business rules. Okay, it encodes business rules which determine how data can be displayed or created or stored. And changed is handled by the OB. Okay, And another thing is that it handles flexibility and communication. Right. So those are two things that are handled by ORB, which is also a type of middleware. And then when it comes to stubs and skeletons in this process, which is involved with the RPC that is used here. So you know what a stub is. So stub at the client side converts the message, and then the skeleton converts it back. So basically you have a client, you have the stub, message goes over the network. At the other end you have the skeleton, and then the server. Okay, right. So so far we talked about we started with talking about centralized and distributed and network systems, and then we spoke about middleware. Okay, we discussed the 8 elements in a middleware. Okay, and we said that the first 4 elements are enough in order to come up with the basic function of it, but the other 4, the latter part, is necessary to establish a proper communication which is reliable and etc. Okay, and then we spoke about RPC, which is a type of middleware, and we said that it hides certain functionalities. We came across marshalling, unmarshalling, which are performed by things called stubs and skeletons in an RPC. So we came up with the architecture where IDL generates a stub and skeleton, and then they establish a connection. So we took an example for marshalling, how it happens, the assembling and the deassembling, we discussed that. And then here we discussed the RPC model to say how the client side communicates with the server side by passing messages and so on. Finally, we came across another example scenario where an ORB, which is a middleware, is used to establish a connection. Okay. Right. Now, since we have covered the first, oh, by the way, remember that these parts will be talked about again in the future lectures. Middleware will be talked about, and RPC also has a separate section. Okay. Right. Now, can we come to the VLE? There's a small task that I would like you all to do. It's not an assignment or anything of that sort. It's just something to just recap what we did. So let's go through the slides now. We discussed the first part, the OSI model and stuff. So RPC, we discussed this in detail. The slide set doesn't have everything that I have discussed in the notebook by drawing and everything. But in the future lectures, all of those things will be included. I just wanted to explain it to you today because otherwise you all won't understand. So Okay, so here in RPC, we discussed that it issues calls and creates connections, marshals data, assembles it to send it over the network, and then unmarshals at the destination. So stubs will do that marshalling, and skeletons are there as well. So that's about RPC, which is a type of middleware. And okay, and then when we come to distributed systems, we discussed this initially at the very beginning of the lecture today, that distributed computing is a set of tightly coupled programs executing on one or more computers and coordinating their actions. So they carry out functions which nobody would be able to carry out alone, simply because they share resources. Okay. So right. So the components are basically distributed, and then a computer that hosts certain parts of this system is referred to as a host, which is basic understanding. And then when it comes to middleware, we said that it is used in a distributed system. So this will coordinate activities while hiding the complexity from the user. Here we talked about something called transparency. If you remember, we said that the requester will not know that the what do you call service is being served by some other provider, even when the provider whom we first contacted is down or broken or whatever. So there's a certain level of transparency as well. So it hides the complexity. Okay. And so the middleware layer in a distributed systems use certain middleware layers in between the application and the network operating system to resolve heterogeneity and distribution. So this is what we basically discuss, saying that two different people cannot communicate, so you need a translator in between, so the heterogeneity is being catered to with the use of a middleware in a distributed system. Okay, I hope you can understand. Right. Then about transparency, which we just mentioned. So the basic idea of this is that you need to hide the complexity of the distribution. Okay. So complexity could be in terms of establishing a connection between the two devices. Plus, it is with respect to marshalling and unmarshalling as well. So it needs to be hidden so that the requester will not even know that a provider is broken down or something of that sort.